Hello, my name is Composite Rich Rope number 3 from class 511.
Hello, my name is Sake Pachamaporn Shah, number 6 from class 511.
Hello, my name is Bob Sakun, number 16 from class 511.
And today we'll be presenting about simple harmonic motion.
So firstly, oscillation and simple harmonic. For the definition for oscillation, the motion that repetitive back and forth, like in the picture, or to and forth motion of an object or a system around a central equilibrium point. And using a pendulum is the best way to represent this motion theory. And for periodic motion, it is when the same motion repeats itself after equal interval of times. We can call it periodic motion. And also in the physics term, meaning the repetition of the same motion in the same amount of time.
The next one is period. Period is a time that the motion moves to the same displacement. For example, in this motion of the pendulum, if we start to look at the pendulum when it is at the equilibrium point, the pendulum will continue go to the position 2, which is the maximum displacement, and then go back to the position 1, which is the lowest displacement, and then the pendulum will come back at the equilibrium point again, and this will be counted as a one period or one cycle. Now we can take a look at frequency. Frequency is the amount of period or the amount of cycle count in one specific length of time. For example, in this simple harmonic motion graph, from the graph we can see that there are 2 cycle count in 1 second. So the frequency of this graph will be 2 divided by 1, which is a cycle divided by second, or the period divided by second, and we will get the frequency for this graph equals to 2 Hz.
We will be explaining what is pendulum. Pendulum is based on a Newton's first law of motion, which states that a body at rest tends to stay at rest, and the body in motion tends to stay in motion with the same speed and the same direction, unless it acts on other unbalanced force. So we can separate this into 2 categories. So the first one is in eternal, where there is no external force acting on it, and in the reality, where there are a unbalanced force acting on the pendulum. So how is this different for visit?
Well, it's different from, okay, let's start at point number 1. Point number 1 is when the acceleration is the highest. Next, wait, let me add. The acceleration is highest at point 1. The displacement is the least at point 1 because it hasn't moved yet, and the velocity is at rest. Next, at point 2, the velocity is now the highest. The acceleration is a second runner up, and first runner up, and then after, and with the displacement as well. And now by the third point, the displacement is at its highest because it has moved the most. The velocity is at rest, and the acceleration is negative. And this repeats itself throughout 4 and 5.
Okay, as the composite said, in the eternal, there's if so there is no unbalanced force acting on the object, so it will not lose any energy, and it will stay looping itself over and over again as the process of that purposes just mentioned. But in reality, there are unbalanced force acting on the object, so as the time passes, the object will be losing energy and lost the momentum, so the object will be stopped at the equilibrium as the time passes.
Simple harmonic motion is it's like a movement going back and forth through a equilibrium position, like this. So the max displacement on one side of the simple harmonic motion is equal to the max displacement on the other side of the simple of the other side. This is therefore F is directly proportional to negative displacement. And like talking about displacement, what is displacement? Well, displacement is the distance between an object and a starting point and ending point, like the fastest way you can get from point A to point B. While amplitude is the displacement that goes either side of the direction, the negative and positive displacement of the motion, as you can see from the diagrams right here. And equilibrium position for a simple pendulum or mass spring system. In this diagram, in this slide, I'll be showing an example of a mass spring system. What is equilibrium position? Equilibrium position is a position where the total force is equal to 0. The weight and the force are equal in size, but they don't go in the same direction. They go in opposite directions. For example, in the diagram in the slide right here, the left one, the utmost left one, is where the spring force is more than the weight, leading to an like unstretched spring. The middle one is when the spring force is equal to the weight, leading to a equilibrium position. While the most right one is when the weight is more than the spring force. These are some diagrams that I've sketched to show the displacement time graph, acceleration time graph, and velocity time graph.
And also, what is about the graph, Ponvisit?
Well, it shows the motion of a simple harmonic, basically. On all of them, they show like what the displacement is when it's moving in a simple harmonic motion, what the velocity is when it's moving in simple harmonic motion, and what the acceleration is. Great question, by the way.
Thank you.
I have also sketched like what is the minimum point, the maximum point, the zero where it equals 0, and as you can see right here, I would like say that 0, right? 0 is when like it's just a line like this. That's the starting point. Next, the next one, right? T over 4. That's when it reaches the middle point. The middle point, like let's say this is 0. This is the middle point. And the next one, T over 2, is when it reaches the most far point from the starting point, right? Right here. Next one, 3T over 4, is when it reaches the middle point a second time. And T is when it returns back to its starting point. So yeah, you can analyze the displacement, acceleration, and velocity. You can see from the graph that the displacement is at most when it's right here, which makes sense. While the displacement is least when it's right here in its starting position. Next, acceleration is at its max when it's starting, and when it comes back and it's ending, right? And is at its least when it goes right here in the middle. And finally, for the velocity, it's at its maximum, right, when it first goes here to here, right? And it's at its least when it comes back here, here, here. When it goes back to the starting point, it's the least. Also, when it starts, it's the least as well. Oh yeah, I forgot to mention velocity is also highest when it reaches here again. When it reaches the middle point again.
Next, we will be taking a look at conversion of gravitational and kinetic energy. Gravitational potential energy is rely on three variants: the mass, the gravitational pull, and the height of the position. For example, if we are looking at this picture, the motion of the pendulum at start or the maximum displacement of both sides, we can see that they are at the highest point of or position of the motion, and the mass and the gravitational pull remains the same. So the gravitational potential energy is the max at this max displacement. But at the zero displacement or the equilibrium position, the height of the ball is at the lowest of all movement in this position, so we can assume that the gravitational potential energy at equilibrium point is the lowest. On the other hand, kinetic energy will rely on mass and velocity, so on the equilibrium position, the velocity is fastest along the motion, so we can assume that the kinetic energy is max at this position. Differently from the max displacement, the motion is at rest, which means there is no velocity, and also we can assume that at this point the kinetic energy is the lowest of all the motion of the movements. And also, if we converted the whole process into a graph, it will be shown that the value of these two types of energy is diversely proportional. The next one is free oscillation. Free oscillation is the motion that moves with their own natural movement without external influence and impulse that initiated the motion. It is also called the free vibration, and it is contrastly different to the forced oscillation when the motion mass when the motion has moves by the external energy. Restoring force. The restoring force is a force that acts to bring a body of its equilibrium position. So the force will always facing to the equilibrium point, as we see from the pendulum. The force will be facing to the equilibrium point that is as it swings both sides. And also the next one, the natural frequency. As I said, it is a frequency that was in the pre-oscillation. So it is also known as the agent frequency. It is a frequency at which a system tends to oscillate in the absence of any driving force or the external influence. And also the oscillation undergoes the set of frequency called natural frequency. So we can also find this in a string mass system and also the pendulum motion of the pendulum.
So the force oscillation. It is the object or system that is oscillating at some frequency as a consequence of external object forcing it. For example, a shaking man sitting on a bus. Next, driving force. A driving force is a force from an external source that is exerting on an object system, making it to oscillate. For example, a man sitting on an engine of a car, and the driving force are from the engine, and object or the system is the man, the force oscillation, and external source is the engine, the one is driving. And for the driving frequency, it's the frequency of the driving or external source that affect the system. Next up is for resonance. Resonance happens when the driving frequency is matching the natural frequency of the system. For example, a father swinging a child. An object of the system is a child and the swing. External source of energy is from the father. The driving force is a push from a blue man, which represent a father. And for the natural frequency is equal to the driving frequency, which causes resonance. And the push needs to be at the maximum potential, not too early, not too slowly, to cause resonance. And also, to increase the resonance, it needs to increase to the amplitude of the oscillation dramatically to the maximum. Next up is damping. Damping is when the driving frequency does not match to the natural frequency. This causes the oscillation to stop eventually if there are no external force. A decrease in amplitude of the oscillation, not in frequency, due to energy loss from the resistive force. As you can see in the graph, that it's slowly decreasing to zero. So there are four main types of damping. First one is light damping, which is a damping that decreases the amplitude of oscillation until it stops slowly and still oscillate. Like a swing of a door or a swing of a child, that it slowly stop but still oscillate. Next one is for heavy damping, a damping that decreases the amplitude of the oscillation until it stops quickly but it still oscillate. Like also, as I said, a swing or a cowboy door that swing and stop quicker than a light damping. Next one is critical damping, a damping that causes the oscillation to stop without oscillation quickly. For example, a hinge of a door that make the door close not slowly but just close without oscillation. To refer to the father swinging a child, the father must push the child at the wrong time, which can cause the child to stop immediately. Oh, yes. For the next one is over damping. It's a damping that causes the oscillation to stop without oscillation slowly. So this is the displacement of the oscillation, as you can see from the graph. The critical damping, it is the one that fastest to the stop, and over damping take quite longer time than critical damping without oscillation, like light damping or heavy damping. And as you can see, light damping take quite more time and quite more to oscillate, and heavy damping use less time. And for the next topic is that why do washing machine shakes for a part of its cycle? So the washing machine shake for the part of the cycle due to the force oscillation. So an object system is the washing machine. The driver or the external source is the cylinder rotating, and the driving force is a force from the cylinder itself. So when the cylinder spin, which can cause the washing machine to shake. And next one, explain what happened with the Tokama Beach in 1940. So Tacoma Bridge collapsed because the wind, the driving frequency, matches the natural frequency of the bridge, equal resonance, then it swing to collapse. So causing a resonance, consequently the amplitude increased dramatically and increased the bridge to collapse, which caused it to swing violently. Next, what had happened to the Millennium Bridge in 2000 and how was the problem fixed? So, the resonance happened when people were walking on the bridge, causing small sideways oscillation, and people sway with the bridge to walk, so that increased the amplitude of the bridge, causing it to swing more and more. So it closed for a bit, and the engineer fixed it by creating a damper. The damper were employed to the bridge, which can absorb the energy when people walk, so it swing less and absorb energy to that damper instead of swinging the bridge more violently. The next one is how tornado at Dreamworld works. So it is similar to the motion with a swing, but the electrical energy is used to be converted to mechanical energy to vibrate the hand of the tornado to swing around, which it's at the circle rotation, which can have a motor swinging to add more rotation to the swing. And lastly, what does this giant ball do for Taipei 101? A giant golden ball hangs suspended beneath the deck of the Taipei 101. This is the wind damper. It generates reaction force to negate shock or vibration caused by the outside force, as I say, so the people inside the skyscraper can live and work in comfort. The next one is the Mahanakorn building and Taipei 101 and how it's similar to how they're built. So, firstly, the base isolation. This technique involves placing a flexible bearing and the building foundation, which can absorb the energy and reduce the vibration of both of the building. And also, both have damping system, which can absorb a lot of energy, and this helps the amplitude of vibration and increasing the resistance of the force. And also structural reinforcement, such as a column, beam, or joint of the part of the building, which enhance the building and which can make the building more stable. And lastly, energy dissipation device, which this device is a fluid damper that can reduce the building response to ground shaking or earthquake. Thank you for listening.